The topic of today's presentation is current solution trends in styrenic thermoplastic elastomer technology. This is presented by me, Prakash, Head of Research and Development, and it's co-authored by. Good morning, everyone. Thanks for being here. Today's topic on the presentation is current solution trends in styrenic thermoplastic elastomer technology. And I'll be presenting. My name is Prakash Sanjeevaiah, Head of Research and Development at Star Thermoplastics. And the presentation was co-authored with Larry Johnson, who is VP of Business Development at Star Thermoplastics. The topic, in today's topic, we are going to cover the market trends in the thermoplastic elastomer businesses. And in particular, we'll focus on the styrenic block copolymer technology. And moving on from the market trends, we will cover a bit of basics, talk about styrenic block copolymers, the differentiating factors, and then how it competes and trying to establish a niche in today's existing competing technologies such as thermoplastic vulcanizates and thermoplastic urethanes. And lastly, we will cover a few of the critical market trends that are shaping up the way we design the styrenic block copolymers and also other thermoplastic elastomers in general. And finally, I would summarize a few key points on this presentation. In this slide, it shows the current global trend of growth, which is an anticipated 6.3% to a 10 billion pound annual volume. And in North America, annual consumption is expected to grow at about 4.7 to nearly 2.4 billion pounds. What is interesting in the bar graph on the right side, you can see how much of styrenic TPEs you can see as a growth component, and it definitely occupies a lion's share in the whole elastomer business's growth curve. This is another way to represent and also talk about regional growth that we are seeing in the thermoplastic elastomer global market. You can see that in the Asia Pacific region, it's about 948,000 tons or so. Most of the growth is seen due to, again, automotive growth, automotive market growth. And the same thing is true with lightweighting and other regulatory needs and few other MPG requirements that are spurting a growth on the use of thermoplastic elastomer in the North American region as well. Moving on, just to give a brief overview of what thermoplastic elastomer is. It is taking a good points from both thermoset rubber and also from plastics. The definite fast-forming, reprocessable, design flexibility and freedom, it is being wedged in plastics, and also from the thermoset rubber, the elasticity and the usual softness that we see, whereas not taking into the relatively longer cycle times we observe with the typical thermoset rubber, and also reprocessability that you don't normally see in the thermoset rubber. So thermoplastic elastomer is basically taking best of both worlds of plastic and thermoset rubber. Moving on from the general thermoplastic elastomer overview to styrenic block copolymers. What I've stated here is the two different definite chemistries that we normally use in the rubber that goes into the formulations. One is the non-hydrogenated or non-hydrogenated and unsaturated mid-block segment that you see as SBS rubber. Typically, they are lower cost. At the same time, they also have lower UV resistant and low continuous process temperature and workable temperature. The next one is more interesting, which is the styrene ethylene butylene styrene or SEBS hydrogenated version. which is higher cost because you have an additional step of hydrogenation using catalysts, and that adds to higher cost, but at the same time you get excellent UV resistance because you do not have many of the unsaturated portions in the elastomeric part that usually contributes to UV. And definitely an increase in the workable temperature. You do see it's a moderate temperature. Some of the key players in the styrenic block segment have also grown up. Some players, rubber suppliers and manufacturers in the Asia Pacific region, we are seeing a definite increase in their competition against the US and Japanese counterparts in the supply chain. More recently, we are also seeing the Shell GTL technology also forming a feedstock for generating some of these rubbers, and many other ways that they are influencing the thermoplastic elastomer market. And I'll talk a little bit more in detail in the next few slides. The styrenic block TPEs, what we have here is a representation of the hard segment that comes from the polystyrene, and also from the softer side, which is more elastomeric, comes from the ethylene butadiene portion. The basic chemistry of both polystyrene as well as the ethylene butadiene is relatively non-polar, and that makes it hard to bond and also print. And some of the recent additive technology has enabled the formulators to kind of overcome the limitations of printing as well as bonding as well. So there is definitely a lot more excitement because of the flexibility in the design of these materials. So moving on from the representation, I will talk a little bit about platform features that you do see with styrenic block technology today. On properties, a wide property matrix, freedom and ability to customize for specific needs, and low to higher modulus that can be tweaked. And again, you start off with a lower specific gravity with all the rubber and any other polyolefin that forms the matrix, and you can build on it by adding fillers and any other ways you can increase the specific gravity. Drilling down further on this platform technology, the features that I can highlight, you have a list of features here. Definite colorability, colorable, it is extremely colorable material, over moldable, cost effective, and also ultra clear materials, some of the displays right here, and medical application, and all this come out of what we call good features that gives you a lot of possibilities. On the functional enhancement on these platform features, you do see higher heat, compression set, ductility, elasticity. And if you utilize those, what you see in the marketplace is the conductive, antimicrobial, radio opacity elastomers that have found quite a number of uses in variety of market segments and variety of applications. How does styrenic block TPE stack up or against the existing thermoplastic vulcanizates and also thermoplastic urethanes? Thermoplastic urethanes, to begin with, definitely have good wear resistance, extremely outdoor type applications. You do find a lot of those. On the vulcanizates, you do see quite a bit of market in automotive sector, and also having a high compression set and a higher workable temperature, you have TPVs as the go-to material. Some of the low-end applications in the wire and cable, styrenic blocks definitely have made some inroads by replacing TPVs. On the thermoplastic urethane side, it is very similar in terms of stretch recovery and some wear resistance applications. Styrenic block definitely have made some inroads. Definite progress has been made to replace quite a bit of medical applications where Some of the PVC and some TPEs were used before. Now they are slowly shifting towards styrenic block as well. This is another visual representation of all the technology platforms that are currently being looked at and also being segregated and drilled down deeper, and that is represented here. And what we do see is the core, clear, ultra soft, ore molding, high performance, surface engineering, and to name a few. And how does this apply to the current market that it is being penetrating? In terms of clear application, we do see ultra clear materials for quite a number of medical, non-medical applications. And because of the nature of the rubber as well as the polyolefin and any other ingredients that form the formulation, we have definite advantage of making some of the best clarity material in the elastomer technology. Ultrasoft is another upcoming place where you do see quite a bit of variation by modifying the tackiness of the product. You do have the best of both worlds, so to speak, in terms of softness as well as non-tack nature. Ore molding is another major interesting sector that thermoplastic elastomers are fine-tuned into, being bonded to nylon, polycarbonate, ABS substrates. Many players in this industry are honing in on specific grades of nylon or polycarbonate or ABS. Additive technology such as modifiers that would increase the surface energy or modify the surface energy of what is available with the styrenic block definitely has helped penetrate more in the ore molding segment. When we talk about surface engineering, as I said, which will in the gel, it is same thing applicable here as well. You can modify the surface feel and the haptics portion of it to customize any application. And same thing is true for vibration damping, which is another place where by adding certain fillers or by other means, we have some grades that have increased comfort and safety. On the non-plasticized versions of thermoplastic elastomers and the styrenic block, specifically designed for low or non-extractable and low outgassing, and that could meet some of the stringent regulatory needs from European Union as well as the FDA regulatory authorities. Some of the critical market trends that we see today that are going to shape up and continue to shape up how designers are going to manipulate the styrenic block TPEs are captured in this slide. The groups are safety, health, environmental awareness, aesthetics, economics in use, and definitely design flexibility and functionality. I'll talk about each of these groups in detail. So when we talk about safety, health, one of the biggest push in the consumer awareness has been the BPA-free food containers, baby bottles, and things like that. The reason is BPA is found to be mimicking some of the hormones that could eventually affect the birth. So there is so much research going on in the BPA free segment, even though not much of decisive things have been uncovered, but the consumer awareness has pushed us to look at BPA free materials. So thermoplastic elastomers, particularly the styrenic block, definitely has made inroads because inherently they are BPA free and also phthalate free. Phthalate free is another one that has other environmental and few other health consequences that were inherently part of the PVC segment. And PVC, as we know, are said to be the gold standard for all the medical applications, tubing, and many other blood bags, and so on and so forth. So with this SBC TPEs, we do see quite a bit of inroads in new applications. Moving on from the BPA and phthalate-free materials to ergonomics. Ergonomics, the aging population are pushing towards more wearable technology that could monitor quite a bit of vital signs, and a lot of data is generated day in and day out from this population. And the push from both from the federal government and the healthcare industry is towards preventative care rather than treatment. So all these have summed up towards developing more ergonomically favorable, haptic, soft type materials that can go into these wearable devices that people can use 24/7 without much discomfort. So some of the soft materials you do find in the TPEs are what we see on the iPhones, iPad, and watches or Fitbit type materials. And how does the styrenic block copolymer technology today is able to stack up and meet the demands of the safety and health needs of today's today's world? And technology that are available under styrenic block copolymer is ultra soft gels, over molding, bondable, medical, and vibration damping materials, to name a few. And how does the technology feature is able to stack up for the demand? It's definitely phthalate and BPA free, low extractable, excellent ergonomic and haptic properties, sterilizable via gamma or any other sterilization methods, and very good support and meets all the strong regulatory requirements that are available. Moving on from the safety and health to environmental awareness, the push is towards a more reusable and multi-use option in the materials that go into today's products. Recyclable, durable, and free of toxins, harmful toxins, and very energy efficient process. So when we talk about all this, thermoplastic elastomer definitely are up for the challenge, and they have non-plasticized, high performance, easy processing, and some of the good packaging materials that are part of the product lines. And the features that come out of these product lines would be durable, recyclable, and a great replacement for PVC, dishwasher safe, and also quite a bit of automotive low-end products that were with metals have been replaced with the TPE parts. So that's an interesting sign of market penetration. Moving on from the environmental awareness to aesthetics, definitely there is a brand enhancement feature that's built into thermoplastic elastomers by way of haptics and feel, and it does impart an image of luxury to the consumer devices, consumer uses of phones, phone or mouse or keyboard, things like that. And it is a very well established study that consumers are much more likely to buy a product if they are induced to pick the product and examine it, touch it, feel it, hold on to it, and grip, grip, tackiness, and all those definitely play a role in how consumers make decisions on buying a product or not buying a product. And this also denotes, when you do have a super clear, ultra clear material, it does denote cleanliness, freshness, or sterile material that the consumer would most likely buy. And some of the technologies that would stack up for the features that could meet the aesthetic demands is clear material, surface engineered, ultra soft, vibration and noise damping materials that form the product lines of thermoplastic elastomers, and they offer crystal clear clarity, extreme colorability, customizable haptics, overmolding to variety of substrates. All these would address or meet the aesthetic demands. The other important factor or the market trend that we are noticing, and there is a lot more push, is the economics. The need for cost containment is drilled down through actual price of per pound of these materials, durability and functionality of the end product, ease of use and reusability, whether you can recycle these parts or pellets or the material or resin in general, reduced waste, higher worker productivity through ergonomic enhancement, and easy processing to bring down the cost. The other way to look at the materials or the final part is lightweighting, sealing, and ergonomics, which will add to the additional benefits of an end user oriented market. If you talk about auto market, you do see anything that enhances MPG would definitely be a plus point for a consumer. So how does the technology in the Styrenic block stack up for what is economics going to demand for? So overmoldable grades, surface engineered grades, and then some of the grades under thermoplastics, thermoplastic elastomers are commoditized so that they add value. So wide range of formulations under the features and costs, excellent durability and reusability, wide degree of functionality, low specific gravity, and no drying, which definitely is a plus for molders or extruders who do use the resins to get to the end product. Last but not the least, the design flexibility and functionalities. As I mentioned, all the other rest of the four are plus the design flexibility and functionality will definitely be the key factors for how the materials are designed. Enhance the user machine interface, allows for visual observance when you have super clear material, allows for identification methods, imparts comfort for orthotics and prosthetics, and definite inroads are made for impact resistant materials that could address some of the breakage and quite a bit of rigorous and extreme environments where the devices are used or the parts are being used. So all these definitely are important market trends that we see, and the demands what we see, and the technologies that are available today, or moldable, ultra soft, vibration, noise damping technologies, are going to offer quite a bit of features such as excellent haptics, low temperature flexibility for weather conditions, UV resistance for outdoor applications, low specific gravity for reducing the part weight, wide hardness range for different nature of the material needs, and good barrier properties where you do need to have moisture resistance or oxygen resistance or oxygen barrier needs. The styrenic block copolymer TPE is definitely are present wherever these needs are critical. So all this would summarize well with, we definitely are looking at all these factors. Definitely there will be many more that will drive the styrenic block copolymers, or in general the thermoplastic elastomer. The way we are going to design, we will see new features being added. Conductive polymers is definitely another one that is taking up shape quite rigorously. There will be many more non-plasticized versions you would see for replacing PVC, or at least share shift the market. And some of the disruptive technology you do see with hybrid systems going forward. Shell gasoline, gas to liquid technology is definitely going to be a big game changer. and so are other additive manufacturers coming up with nanotechnology additives that will shape up a few niche markets. To summarize, the Styrenic TPE will continue. We hope and we do see that the global consumption is with a growth rate of 6% to an annual volume of 10 billion pounds or so. The factors that will affect how the TPEs are designed and will be used will come under design flexibility and functionality, safety and health, environmental awareness, aesthetics, and economics and use. So it is definitely exciting times for thermoplastic elastomers and for styrenic block TPEs in particular. Hope this was interesting and useful. Definitely there are a lot more things that could be dealt into detail. Hope I would be happy to answer any questions, and thank you for listening.